All right, everybody. Our first topic in physics today is going to deal with the difference between distance and displacement. Sometimes misconstrued to be the same thing, but they are different. So let's talk about the definitions first and do a couple of examples in today's video. So as you can see, distance is the total length that you travel, and it's reported as just a number. You just add all the numbers that you're traveling and you get a final result. And it'll just be a number without regard to direction. Well, displacement, on the other hand, deals with a number and the direction. So that's the main intrinsic difference between the two. So let's do an example of distance. Let's say I start off, well, before that, let's talk about this number line here. So all the numbers in the number line, we're going to start on the x-axis, and even in the y-axis, basically the same stuff. So in the x-axis, the positive numbers are in the easterly direction, the negative numbers are westerly direction, and on the vertical axis, the positive numbers are in the northerly direction to the north, and then the negative numbers to the south. So an example of distance would just be if I started at -3, went to +3, and then came back to -3, I just add all the numbers together and I just get a total distance. So I went 6 units to the right, and I go 6 more units to the left, add those numbers together, I get 12 units of distance, as you see here. So this is 12 units of distance. Now let's take the same two numbers for displacement. Displacement is a difference between any two positions. The deal with this example is that the initial position and the final position are the same thing, but we can still obviously calculate the displacement. So in calculating the displacement with those two positions being the same number, we have the formula for displacement, delta x equals final position minus initial position. And we see that the final position is -3 minus the initial position, which is also -3. We started where we end up where we started. So -3 plus 3 is 0 units of displacement. So for the same two numbers, we can clearly see by definition and calculation that distance and displacement are not the same. In this case, and sometimes they can be. Like, for example, if I started at -3 and ended up at +3, it'll be +3 minus -3, which will be 6. But that's obviously not the case in every situation. Sometimes it can be the same, but most times they're not the same. By definition, they're not the same by definition, but sometimes in value they can be. So just to go back over here, let's see if I can get to my first slide. It won't let me do it. Okay. But yeah, just to repeat that, distance is the total number, -3, +3, back to -3, 6 units plus 6 more units, 12, but displacement, -3 minus -3, 0 in this case. And so for another example of displacement, let's say that I start off at +7, and I went to my final position of -12. Well, +7 would be in the eastern domain, and then I travel to the west, -12 units from 0, or I wind up at the position of 12 units to the left of 0, or -12. You get the idea from algebra. So +7 is my initial position, final position -12. And then my displacement would just be delta x, final position minus initial position. I have negative 12 minus plus 7, it's just a subtraction. Negative 12 minus 7, negative 19. Negative 19 units, or 19 units to the west. So in displacement, the sign matters. Negative sign is to the west, positive to the east. So when you get a result in displacement with a negative sign, like here, that means 19 units to the west. If it was plus 19, it would be 19 units to the east. And let's see if the first slide's going to work. Nope. But that's pretty much it. Distance is a number. Displacement is a number and a direction. Um, yeah, and obviously, of course, the same way in the y-axis. And we'll do more of that next time. So hope you enjoyed the video and talk to you later.